Hello, everyone, and welcome back to our discussion about the unit circle. So, last time we talked about unit circle and we divide it by its axis. So, we have four congruent arcs, you know what I mean, or four divided arcs. Okay. Now, what if we have a square inside the unit circle or an inscribed square? So, we have a square here. Let me just draw the wait. Let me just draw the rest of the lines here. Okay. I would like to include the origin as well. Okay. So imagine this one. Okay. So what are we going to do? In here, we're not going to find the arc length anymore because we already knew what will happen. Okay. What would be the angle form? Okay. Its magnitude is the same as the magnitude of the arc length. Okay. So if we have 90 degrees, which is pi all over 2 radians, the measurement of the arc length would be also pi all over 2 units. Okay. So the magnitude of the angle in radians is the same as the magnitude of the arc length. Okay. So we're not going to do that anymore. Now, what we're going to do is we're going to find the vertices. Oh, wait, no, the coordinates of the vertices of the square. So this one. In other words, the corners of the square. Okay? Let's recall that in a square, of course, all sides are the same. So if this is 3 units, that means all sides should be in a length of 3 units. Okay? Then the corners, they have the same angles. And that is 90 degrees. So this is 90 degree, 90 degree, 90 degrees, and 90 degrees. Okay? Now, what if we cut the square into 4 squares, just like this one? You know what I mean? Like, this is a whole square. Now, imagine this one's been cut, or yeah, being cut by the axis. So we have 4 squares. I mean, 4 congruent squares, or the same squares. We have 1, 2, 3, and 4. 4 the same squares. So imagine that. Okay? What will be the angle in these corners? It's still 90 degree. It's still 90 degree, 90 degrees, 19 degrees, 90 degrees, 90 degrees, and so on and so forth. Okay? This is actually basic geometry. Okay? So I'm just recalling it for you. Now, here's the thing. Okay? What we're going to do is we're going to find the coordinates of these vertices. Okay? So let's start on the top right. Okay? Let's just say we go here. Okay? From here going there. Okay? From here going there. So first and foremost, what would be the angle form here? What will be the angle form? Here you see, what I did here is I basically made a line that shows the distance between this corner up to that corner. So from this up to that corner. Okay? From this corner up to this corner. Okay? So what happens? If that's the case, you know what will happen to the angle? Right? This is 90 degree initially. Now that now that we have a line that shows the distance between from this point up to this point, what happens is that the angle here is bisected. That means it's cut into two. So 90 divided by 2, we will have 45 degrees here and 45 degrees there. So in other words, the angle here is 45 degrees. So this is 45 degrees. Okay, this is 45 degrees. All right. And of course, again, this is 90 degree. Okay, 45 degrees, 90 degree. Okay. So this is 45 degrees. So what's next? Let's find out the coordinates. Can you guess how? How will you find the coordinates? You don't know. Okay. So this is where right triangles come in handy. Okay. And these right triangles are not just right triangles, but they are special right triangles. So here, let's recall that there are two special right triangles, 30 degrees, 60 degrees, 90 degrees, right triangle, let's just put it as RT in short, and 45 degrees, 45 degrees, 90 degrees right triangle. Okay? These two triangles, right triangles to be particular, gave us the exact value of each side of the right triangle. In here, we're going to focus on this one. Why? Let's get this one, okay? Imagine we cut this piece off. So we have this one, 45 degrees. And remember, this is also 90 degrees. So in here, if we have 45 and 90, expect that this angle is also 45 degrees. That's why it's called 45, 45, 90. So for example, if this is missing, but you have 45 degree and 90 degree, that means the missing angle here is automatically 45 degree. Okay? What if you have 45 and 45 only, but you don't know what's the next interior angle? Then expect that the other interior angle is 90 degree. Okay? So hence you have this one. So you have 45 degree here and 45 degrees here as well. Okay, so now what? So now what? Remember that in the, what do you call this one again? In the special right triangle, to be particular, 45, 45, 90, okay, let this be your hypotenuse, okay, and these are your legs, okay, these are your legs. If you have 45, 45, 90 right triangle, these two legs should have the same measurement, okay, these two have the same measurement. So for example, if this is 3 units, then that means this is also 3 units. Okay? Remember that. Now, here's the thing. As I said earlier, they're called special right triangles because you can get their what? Their exact value or, yeah, exact value of their legs. Okay? So, these two legs, the values would be h times square root of 2 all over 2 and h square root of 2 all over 2. These are what? The values of your legs. They're both the same. All you need is to find your hypotenuse. Okay? So, you see, the, what do you call this one? The terminal side is located here. Okay? So that means the radius of the circle goes from here, then going here. Okay? So if you have a radius from here going there at up to an endpoint, it's still 1. Remember that the measurement of the radius at any point is 1. Like for example, measurement of radius from here to there is still 1 unit. From here to there, which is exactly at the corner of the square, it's still 1 unit. The same thing here. From here to there, uh, which is also the position of the, what do you call this one? The corner of a square is also 1 unit. So therefore, the hypotenuse is 1. Okay? Oh, wait, hala. Wait. Okay, there you go. So it's still 1 unit. So we're going to erase this one. Okay? So if we have 1 unit, ah, wait, let me change the pen color. So we have 1 unit here. That means, right, remember we have h and h here. So that means you will have 1 times square root of 2 all over 2 and 1 times square root of 2 all over 2. So hence, you have square root of 2 all over 2 as the height and the base as square root of 2 all over 2. Okay, so this one is, once again, square root of 2 all over 2. And this one is also square root of 2 all over 2. Okay, square root of 2 all over 2. Okay, now, what's the purpose? Or, yeah, what is the purpose of this one? Like finding the side of this? For you to find the vertex. For you to find the coordinates. Okay? For you to find the coordinates. Okay? So since, wait, let me erase this one. Okay, let me erase this one. Okay? So since this one is let's just say, wait. Let me draw the the axis. Okay. Okay. It's here, right? It's here. Okay. So what can we observe? Well, first and foremost, the uh, wait. The distance between the corner up to here is actually what? 1 unit, right? Which is actually what? Which is basically going from the what? From the origin to here. Okay, I just basically what do you call this one? Rephrase it for you. But yeah, basically it's starts from the origin. Okay. So now let's find the coordinates of this one. Wait. Why am I writing it here? So let's find the coordinates. So here we can use the legs of the right triangle. So from here, going there, so here this is what? Square root of 2 all over 2, right? So that means, okay, horizontally speaking, you move square root of 2 all over 2 units away from the center going to the right. So that is your x. Then here, going up, okay, since we're talking about y values from here going upward, so here it's also square root of 2 all over 2. So that means you move square root of 2 all over 2 away from the center upward. So hence you have the coordinates of square root of 2 all over 2. Okay? So these are the coordinates. Okay? So wait a second. Okay. Before we proceed finding the vertices here, here, and here, of course. Okay? Let's observe first for a moment. Okay? Let me erase this one. Okay, for a while. I couldn't erase all the inks here because I might erase the drawing here, which is the important part of it. Okay, so here. So, you see, we have a square. Okay? And we divide it into 4, just like this. Okay? It's been divided into 4 because of what? Because of the axis. Okay? Because of the axis. So, okay, this is 90 degree as well. 90 degree, 90 degree, 90 degree, 90 degree, 90 degree, 90 degree. Basically, all corners have an angle of 90 degrees. Okay, all corners have 90 degrees angle. Okay, so here's the thing. If I draw a line diagonally that connects this point up to the corner, okay, from here to there, what happens again? The angle here is bisected, meaning it divides into 2. So you have 45 degrees here and 45 degrees here, right? So similarly, in this case, it's been also bisected, so you will have 45 degrees. But, sorry, I got choked for a second. But what if we also do the same thing here? Because you see, if we draw a line between the corner and the origin, I think the result is the same. Because remember, this is 90 degree, 90 degree. So here, if I'm going to connect it to there, what happens? They also bisect. So this is also 45 degree and 45 degree. Similarly, if we connect here to there, the answer would be uh, 45 degrees, then outside 45 degrees, then here it's also 45 degrees. And lastly, the same thing, if we connect here to there, diagonally speaking, what will happen is that you will also have 45 degrees outside, and 45 degrees here, and 45 degrees here. Okay? So, what do I mean? It means that since you guys have, since this one, connecting here to there will give you also 45 degrees from here to there will also give you the length of 45 degrees, and here to there will also give you a length of 45 degrees. What does that mean? It means they have the same coordinates, numerically speaking. Okay? Numerically speaking, they have the same coordinates, but the only difference is the signs. Okay? So that means we can have square root of 2 all over 2, square root of 2 all over 2. And here it's the same, square root of 2 all over 2. Okay? Square root of 2 all over 2. And the same thing here as well. We will have square root of 2 all over 2, square root of 2 all over 2. What we're only going to change is the signs. Again, why are they the same? Because of the angles. Okay? We have 45, 45 degree, 45, also 45 degree here, 45, also 45 degree, and 45, also 45 degree. Okay? So remember, in your basic geometry, if you have two angles, like for example, 45 degrees, 45 degrees, that means you have two the same legs. Whatever will be the height, that will be also the base, which explains why earlier we have the given coordinates of square root of 2 all over 2. Okay? Now, how are we going to change? Okay, like how are we going to change the sign? It depends on what quadrant they are. But before that, let's try to have the angle first, because right at the first place, we rotate here to 45 degrees. So we have these coordinates, right? Well, how about this one though? So let me erase everything, okay? But now at least you get the idea, all right? So wait, let me erase this one, okay? Hold on. Okay, let me erase this one. Okay, let me erase this one as well. And this one. And this one. Okay. So here you have square root of 2 all over 2. Now, oh, whoa. I erased the line, the white lines again. So now, what if it's here? Okay. Well, if you would observe, okay, if you're going to rotate from here up to there, which is this one, by the way, this is 135 degrees. And remember, I said that whatever your coordinates here, numerically speaking, is also the same value here. Okay, but we're just going to change the sign. Okay, so remember, again, they're the same, but the signs, no. Okay, so here in this side, okay, the only negative here is this one, negative square root of 2 and positive square root of 2. Why negative square root of 2? Because here, if you're going to get the distance between the origin up to here, the answer is still square root of 2 all over 2, right? But since it goes to the left, so this one, the left part, should be only negative. Okay? This should be only negative. Okay? I hope you, what do you call this one? You have seen my handwriting here. Okay? If not, can I try another one? Maybe this will do. Okay? Let me rewrite uh, everything here. Okay? Hold on. Okay, that's it. I hope this one is already readable or clear. Okay? So that's it. This is 135 degrees. Okay? Now, what if you exit further until you reach this point? Wait. You've reached this point. So let me erase this one. Okay? So from here, from the initial side and going there, you will form an angle that is exactly 225 degrees. Okay? 225 degrees. All right? Am I right? Really? 180 to 10. Yeah, correct. 225 degrees. So here, again, numerically speaking, they are the same, but the sign should be changed. So this would be negative square root of 2 all over 2 and negative square root of 2 all over 2. Why both of them are negative? Let's start first in horizontal orientation. So you see, in distance, okay, the distance between this point up to the origin, horizontally speaking, it's square root of 2 all over 2. But it goes to the left direction, so it's negative. Similarly, okay, the distance between the center, or rather the origin, up to the point, vertically speaking, is also square root of 2 all over 2. But since it goes down, like going downward, down, okay, vertically, so it's negative. Okay? Now, last but not the least, what if we, what if we reach up to here? From here up to here. So what will be the angle form? Okay? The angle form here, which is from start up to the last corner of the square. Wait, let me just fix that. Okay? From here, once again, from here, wait, let me just draw the line. Okay? From here, going there, okay, from here going there, you will form an angle of 315 degrees. Okay? 315. Wait, yeah. You know what? Wait. Let me fix this one. All right? So once again, it's 315 degrees. Okay? So again, numerically speaking, they're the same, but signs are different. So what do you think will be the coordinates here? The answer here is square root of 2 all over 2 and negative square root of 2 all over 2. That's it. Why is it that the y is negative? Because horizontally speaking, okay, the distance from here going there, it's square root of 2 all over 2. And since it goes to the right direction, so it's positive. However, here on the vertical orientation, yeah, the same distance, okay, it goes square root of 2 all over 2 units away from the center, but it goes downward. So it is negative square root of 2 all over 2. Okay? So these are the coordinates if you have the angle of 315 degrees. But remember, we are not only going to include the angles that we learned before as a basic, like 0 degree, 90 degree. No. We're going to also include its coterminal angles. Okay? So once again, we do not only include the basic number of angles in degrees or in radians, such as 0 degrees, or the interval of the angle from 0 degrees up to 360 degrees, but we are also including their coterminal angles. Okay? So that's it. All right? So in summary, wait, let me just erase this one. All right? Okay. So in summary, if you have 45 degrees and other coterminal angles of it, you will end up, wait, the grammar here is wrong. Okay. But I think you get my point. Okay? You will end up having the coordinates of square root of 2 all over 2. Okay? Next, 135 degrees and other coterminal angles of it, you will end up having the coordinates of negative square root of 2 all over 2 and square root of 2 all over 2. Okay? Then here, if you reach 225 degrees and other coterminal angles of it, you will end up having a coordinates of square root of 2, negative square root of 2 all over 2 and negative square root of 2 all over 2. And lastly, if you reach 315 degrees and other coterminal angles of it, you will end up having, oh, no, this is wrong. Okay, this is positive, forgive me. You'll end up having positive square root of 2 all over 2 and negative square root of 2 all over 2. And that's it. That's a summary, basically. Also, I would like also to share technique. If you see angles that are divisible by 5 like this, 45 degrees, 135 degrees, 2 to 5 degrees, and 315 degrees, expect that you will have the coordinates of square root of 2 all over 2. But the signs may differ, and it depends on their quadrants. Okay? So I think you get my point here. Okay, guys? So once again, if you have angles that are divisible by 5, expect that numerically speaking, you will have this as your coordinates. But the signs may differ. Okay? So that is all, guys. All right? That is all. So let's proceed to the last part. What if we have hexagon inside the unit circle? So see you soon.